Hello everyone. In this video, we cover the whole life insurance. Just like the previous videos regarding the term insurance, we consider the annual discrete case, that is, the death benefit is payable at the end of the year of death. Consider the whole life insurance, which is an extension of an N-year term insurance issued to an individual at age X, death benefit of 1, and no matter what year the death occurs. Let Z be the present value random variable for this insurance, and we have a table of the PMF of Z. Z equals nu to the power kx plus 1 for kx equals 0, 1, 2 up to infinity. The expected value of Z, by definition, sum up the product of the present value nu k plus 1 and the probability k bar qx. K bar qx can be expressed as kpx times qx plus k. The actuarial notation for whole life insurance issued to an individual at age X is AX. The second moment, by definition, we have the summation nu to the power 2 times k plus 1 k bar qx. A similar expression, except that we are evaluating this at a double force of interest. So we put a pre-superscript 2 to AX, we have 2AX. And then the variance. If there's a limiting age, then the upper limit for k is the omega, the limiting age, minus x, the current age, minus 1. And now with death benefit bk, where the death benefit is payable at the end of the year of death if death occurs between ages x plus k and x plus k plus 1. The PMF of Z, similar structure. The expected value of Z, we have this expression, and then the expected value of Z squared, and then the variance. With limiting age, the upper limit for k is omega minus x minus 1. All right, let's take a look at an example. Given that Q40 plus k is 0.03 constant for all k greater than 0, and the rate of interest I is 0.05. Find the variance of the present value random variable of a whole life insurance issued to an individual at age 40, death benefit $1, payable at the end of the year of death. This is the expression for the whole life insurance AX. We have A40, and then the expression. We need to get an expression for KP40 as well as Q40 plus K. Q40 plus K is a constant 0.03. We get P40 plus K is 0.97. And then KP40, this is P40, P41 times up to this, which is 0.97 raised to the power K. We get an expression for KP40 and Q40 plus K is 0.03. Doing the substitution, and this forms a geometric series. Upon calculation, we get A40 equals 0.375. This is the expected value of the present value random variable, the expected value of Z, or A40. The second moment, similar calculation. The second moment is 0.226415. And then from this, we can get the variance. The variance is the second moment, the superscript 2 A40 minus the square of the first moment, A40. And we get the answer 0.08579. Another example, a whole life insurance of 1, that is the death benefit is 1, issued to an individual at age 25. Death benefit payable at the end of the year of death. Mortality follows the Morpheus law. Omega is 120. Interest rate 0.05. Calculate the single net premium. That is the present value or the APV, the actuarial present value. All right, so we have the limiting age, omega equals 120. So for the expression for AX, the upper limit for K is omega minus X minus 1, and X is the current age, 25. So the upper limit is 120 minus 25 minus 1, we get 94. And then the expression here, due to the power K plus 1, KP25 times Q25 plus K. The De Morphius law, TPX is omega minus X minus T over omega minus X, and the expression for TQX is T over omega minus X. We need KP25. We get this expression 95 minus K over 95, and Q25 plus K is 1 over 95 minus K. Substitute into the expression here. KP25 times Q25 plus K can be simplified to 1 over 95. The terms 95 minus K cancel. And here we have an expression, the summation, K equals 0 to 94, new K plus 1. If we write this, expand this, the second expression is simply the annuity immediate, A angle 95. Upon calculation, we get the single net premium, A25, equals 0.208483. Here's the summary. The PMF of the N-year term insurance, as well as for the whole life insurance. The corresponding expected value of Z, the corresponding notation, and then the expected value of Z squared, and the variance. That's it for today's video. In the next video, we will cover pure endowment. Thank you, and see you in the next video.